In this video, we're going to talk about adding and deleting vertices. In particular, we're going to define a vertex-cut set and a cut vertex. There's an edge analog to this, so we're going to define an edge cut set and a bridge. We'll also see what the join of a vertex with a graph is, and we'll define the edge complement of a graph. When you delete a vertex from a graph, clearly by what it implies is you remove the vertex. But what else must you remove from the graph? So consider the example below with the vertex W. If we delete the vertex labeled W, then would we necessarily have to delete the edges that are incident to W? And the answer to that is yes, because it takes two vertices to define an edge. So if you remove one of the end vertices, you have to remove the edges that are incident to it. So first, we can think of removing all the edges incident to W. And then we delete W. And this is the resulting graph that we obtain if we delete the vertex W. More formally, we define the vertex removal in this way. If it is a vertex, then the vertex deletion is a subgraph which we denote by G minus V, and it's a subgraph induced by the vertex set of G without V. The edge analog, as you would expect, is the edge deletion subgraph, which we denote by G minus E, where it is the subgraph induced by the edge set of G without E. We have two important definitions that are associated with the connectivity of a graph. One is the vertex cut, and one is a cut vertex. So what is the difference between the two? A vertex cut is a vertex set whose removal from the graph disconnects the graph, or more correctly to say, whose removal increases the number of components. On the other hand, a cut vertex is a single vertex whose removal disconnects the graph. Now, every graph has a vertex cut set, but not every graph has a cut vertex, because a cut vertex is a graph whose removal disconnects the graph. So back to our first example, we saw that when we remove the vertex labeled W, we have the resulting subgraph has two components. Therefore, W is a cut vertex. Also, the set that contains just W is a vertex cut set with just one element. The corresponding definition for edges. We have an edge cut in our graph is a set of edges whose removal increases the number of components in the graph. And a single edge is called a cut edge, or sometimes it's called a bridge, if its removal disconnects the graph. So let's take an example where the original graph has more than one component. So in this example, we have 1, 2, 3, 4 components, One of the components is a single vertex. One of the components is a single edge. One of the components is a path of length 4. And then we have our larger component. The red edges are all bridges. So if you remove a single red edge, we'll increase the number of components from 4 to 5. Notice that the edges that are not red are not bridges. If you remove a black edge, you still just have 4 components. It's an observation that each of the black edges are edges in a cycle. So adding vertices or adding edges to a graph, what happens there? We can add a vertex to a graph simply by adding it to the vertex set. Adding a vertex does not necessarily increase the number of edges unless you specify the neighborhood of the new vertex. We can add an edge by connecting 2 vertices who are not connected in the original graph, and so adding an edge does not necessarily increase the number of vertices. So these 2 operations are called primary maintenance operations. Now, an example of something that's not a primary maintenance operation is called a join. If we add a new vertex to a set of pre-existing vertices and connect it to these pre-existing vertices, then this is called a join. And this is not a primary operation because we've changed both the vertex set and the edge set. Another primary, or rather secondary operation is determining the complement of a graph. The edge complement of a graph is the graph using the same vertex set, but then 2 vertices are adjacent in the complement if and only if they're not adjacent in the original graph. So let's consider this example. If we join the vertex x to the graph that we obtained when we deleted w in the previous example, then you see x is completely joined or connected to every existing vertex in the graph. So if you have a graph with 7 vertices, and you join a new vertex x, then necessarily the new vertex will be of degree 7. So we saw some definitions here on adding and deleting vertices. We defined a vertex-cut set and a cut vertex. We defined an edge set, that is a edge-cut set, and a single edge, which we call a bridge. We define the join of a vertex with a graph and the edge complement of a graph.